In this video we're gonna take a look on average rate of change and slope. First of all, we have to remember that when we're talking about slope, we're talking about a line. Slope is actually a constant rate of change of a linear function. Now, if we don't have linear function, like in our example, what should we do? Because if we take a ruler, it has always, on all intervals, it was different slope. Like here it's one slope, here different slope, different slope, different slope. What should we do in this case? In this case, when we have a lot of not a linear function, or we have a lot of different slopes, we're talking about average rate of change on an interval. And let's take a look on one of them, on one of the average rate of change. Now we have 2 points, x equals 2 and x equals 4. To find their average rate of change, we're just taking the values of function at these points. At x equals 2, we have approximately y value is approximately 10. At x equals 4, it's our y value approximately 80. Now to find it, we're just looking for a slope of line segment between these 2 points. To visualize average rate of change, we just connect these 2 points. Okay, we connect these 2 points, and now our average rate of change is actually a slope of the line between these 2 points. And slope of the line, how we know from the lesson, it's actually changing output over changing input, or changing y over changing x, delta y delta x. And let's find slope of this line. Slope of a line segment is equals to changing output, which is 80 minus 10, 80 minus 10, over changing input 4 minus 2, and it's equals to 70 over 2, and it's equals 35. Now 35, what is this exactly? Like we found, it's actually slope of our line segment, and in the same time it is actually an average rate of change of our function, our y function, on the interval between 2 and 4. And now we can write it down here. The slope of our line is 35, and in the same time the average rate of change in y on the x between 2 and 4 is 35. Okay, now also average rate of change can be represented in different form as f of b minus f of a divided by b minus a. This is actually formula known as the average rate of change. Now if we taking different points from our graph on a equal 1 and b equal 3, these 2 points, we can find the average rate of change. Now again, what we have to find? We have to find f of 1, because now our formula f of b minus f of a will be equals, if we're taking these points, f of 3 minus f of 1 over 3 minus 1. What we have to do, we have to find these values. F of 1, if we have function, we can just plug in and find there, or we can use our graph, because we don't have any function, and find these values. Our graph, f of 1 is equals approximately 4, f of 3 is equals approximately 28, and actually we're looking for average rate of change. But how you remember from previous example, average rate of change is just our line segment between these 2 points, and we're looking just for the slope of this line. The same representation as average rate of change. Now, how to find the slope of a line is the same how we did before, and we have to find difference in output. To find difference in output, we have to find this output. F of 1 is equals 4 F of 1 from the graph. F of 3 from the graph we found it was 28. Now our average rate of change, this is the formula, is equals F of 3 is 28 minus 4 is F of 1, and 3 minus 1 is 2 is equal 24 over 2 is 12. And now again, what is this 12? 12, it's in its average rate of change in y between values 1 and 3, and it's 12, and in the same time it's a slope of a line segment between these 2 points, and it's again 12. And that's it, just what you have to remember.